Hi, in this video we will learn how to identify null hypothesis. Here we go with the problem statement that a company has 1200 employees in total and it has three departments: production, marketing and finance. And these departments are governed by the management. Now the production department has 700 employees. The HOD of this department reported that the mean time spent relaxing by the employees under him is not more than 3 hours per week. Now, what is the meaning of this? The HOD went through the employees' records of several weeks and observed that the mean time of each employee per week was not more than 3 hours. That means out of those several weeks, the mean time of an employee may be 2.7, 2.8 or 3, like that. Correct? Now, however, the management have reason to suspect the HOD's claim. Now, what the management did, it collected a random sample of 90 employees' records from that department and revealed that they spent an average of 4.5 hours relaxing the previous week with a standard deviation of 1.3 hours. That means the management went through the records for the previous week only, that means 1 week, regarding those 90 employees, and they found this figure that 4.5 hours was the mean time of those 90 employees in the previous week only. Now we have to test whether the claim of the HOD of the production department is false with a significance level of 2.5%. I hope the problem is clear to you. So we see a statement 1 that the mean time spent relaxing is not more than 3 hours per week, that is mu less than equal to 3, and this was done by HOD. The statement 2 says that the mean time spent relaxing is more than 3 hours per week. Now the point here is that the management didn't go through all the weeks what the HOD did, but the management relies on the records for the previous week only, that is 1 week, and they claim that the mean time reported by the HOD is wrong and it is more than 3 hours, right? So mu is greater than 3 done by management, and that is the claim, right? So this one is the existing report, and this report was challenged by the management, right? So what is the research hypothesis? This research hypothesis is also known as alternative hypothesis. So since management is claiming the existing report, so the claim mu greater than 3 done by the management is our research hypothesis, right? So this one becomes H1, that is alternative hypothesis, and this one is H0 or H0, that is our null hypothesis, correct? Now regarding null hypothesis, we have to say something. This hypothesis is always assumed to be true. So we should try to disprove or reject the null hypothesis. If we can reject the null hypothesis, then the alternative hypothesis will be accepted. And if we cannot reject the null hypothesis, that means we fail to reject the null hypothesis, then the null hypothesis will be accepted as true. Now we summarize the data here that population size capital N equal to 700, not 1200, because we are dealing with the production department only, right? Population mean is 3. Why? See, the statement 1 is demanding that not more than 3 hours, and the statement 2 is demanding that more than 3 hours. That means if we take mu equal to 3, then this is the most conservative configuration, that is the least favorable situation through which we can get the unfavored or unbiased estimate, right? Our sample size small n is 90, sample mean x bar is 4.5, and sample standard deviation is 1.3. Now we have the degree of freedom as 89, which is small n minus 1, and we have a significance level of 0.025, which is equivalent to 2.5% here. Now, which test should we use? Z test or t test? let us see the criteria of z-test. If your sample size is less than equal to 30, but your population variance sigma square is known, then you can go for z-test. Or if you have your sample size small and greater than 30, but your population variance is known or you do not know the population variance, then also you can go with the z-test. In that case, the sample variance will be treated as the population variance, right? And in case of t-test, if you have your sample size greater than 30, you can go ahead. Or if your sample size is less than equal to 30 and your population variance is unknown, then you can go with the t-test, because t-test does not require the population variance actually, it requires the sample variance, right? Now in our case, we have the large sample size. So since we have a large sample size that is much higher than 30, then we can treat the sample variance as population variance and we can use the z-test. Now since the sample size is high, for that reason you have a higher degree of freedom, and for that reason the t-distribution will approach normal distribution, and as a result there will be a negligible difference between a z-score and the t-score. Now here is another question: whether our test is a left-tailed, also known as lower-tailed, or right-tailed, also known as upper-tailed. You see the H1, that is the alternative hypothesis. It is telling that mu is greater than 3. When it is showing like this, then you should say that it is a right-tailed test. This is another question: whether our test is an one-sampled or two-sampled. Since we have only one sample and you want to compare with the population mean, then our test will be a one-sample z-test or one-sample t-test, right? Now a little bit about z-score and t-score. It is nothing but a measure of how many standard deviations below or above the population mean a raw score is. That means if the score is say 2, that means it is 2 standard deviations away from the mean. If it is 1.9, then it is 1.9 standard deviations away from the mean, correct? Now here we go with the formula for z-score, that is the sample mean minus population mean by the standard error, that is sigma by root over n. So we plug in the numbers here and we get 10.95, right? Now we get the z critical, that is the critical value of z at alpha equal to 0.025, and it appears to be 1.96. Now I will show you how to get this figure easily without considering the table. I will take you to a good website I found. I found it suddenly by the Google search engine, criticalvaluecalculator.com, and it is very handy. They have given the tabs here. The t value, you can go for the significance level and the degrees of freedom. For the z value, we can go for the significance level. We have the significance level as 0.025. We give the entry here and press the calculate button, and you get this z value here, and we have a right-tailed, left-tailed, all those values you can have. So it is actually 1.959, that is equivalent to 1.96 for the z value, okay? And for the t value, press the tab of t value, provide the alpha level to 0 to 5, and we got actually 89 in our degrees of freedom because we have got 90 as a sample. So write here 89 and press the calculate button, and it will give you this result, that 1.987. And for the left tail it is minus 1.987, and for the two tailed it is plus minus 2.2798. It's appropriate. It is actually matching with the table, right? So let's get back to our slide. So according to that website, we got this figure 1.96 is the critical value of z at alpha equal to 0.025. Now we go with the t-score. A similar formula is there, only there's a change that in place of population standard deviation, here we have got the sample standard deviation S, in our case, we are treating the population standard deviation as a sample standard deviation, and we get this 10.95. Here, the critical value for t at 0.025 with degree of freedom 89 is 1.98, and you can see that it is almost similar, very near to each other, 1.96 and 1.98. So we see that the z-score and t-score both are greater than the z-critical and t-critical respectively. So we conclude that we reject the null hypothesis H0 in the light of the given data. That means whatever data you have got, based on that you are rejecting the null hypothesis. So this is very important, this one, okay? You always write this thing that in the light of the given data, you are taking the decision regarding rejecting or not rejecting the null hypothesis, okay? So let us see graphically how it looks like. So you see here, z-score and t-score both are 10.95. So if you draw the figure like this, then this is our mu, that is the mean, equal to 3. And here the z is 0. Okay, so this point is actually coinciding with the mu. So there is no deviation, so z is 0. Now suppose this point here, this z critical is 1.96. Then this area will be the rejection area, right? So your score is 10.95. That means it is far beyond this point, that is 1.96. And it falls inside the rejection area, right? So that is why you are rejecting the null hypothesis based on the given data, right? So I hope you understood actually how to identify null hypothesis, alternative hypothesis, and how to take decision of rejecting the null hypothesis or not rejecting the null hypothesis. Now let us assume that I change the data here and you get a z-score or t-score that is equivalent to say 0.92. So in this case, the 0.92 may be somewhere here, right? This is an assumption. So this is 0.92. So this is the accepting region, right? So in that case, you will say that we fail to reject. I am writing it over here. We failed to reject. Failed, right here, failed. We failed to reject the null hypothesis in the light of the given data. Never say that we accept the null hypothesis, because we are not going to accept the null hypothesis because we have already assumed the null hypothesis to be true. So there is no question of further accepting that, right? Now, since we have assumed the null hypothesis to be true, then why we are going for testing? Then definitely our test will be to disprove the null hypothesis, what we have assumed, right? So that is why we do not write we accept null hypothesis. We say that we failed to reject null hypothesis. Clear? I hope it's clear to you how to identify null hypothesis and alternative hypothesis, and also how to get the z-score and t-score, and based on your score, how you reject or fail to reject null hypothesis. Well, we meet in the next video.